I am so happy to see you in the last part of this entire tutorial. The last part is all about our game, saving Zortan, and in this final project we would be actually implementing how to think in layers. First we will write all of the code and then I will try and explain why we did what we did. So for starters, I have created a folder called as project 2 saving Zortan. As you can see, it's all empty. So let me go and let me copy my file. It's right inside my section number 6. Let me copy this and let me paste inside my project number 2. Let me open up the project in a new window. So I can say I want to open my project number 2. And that's it. We have a nice and clean slate to work with, and this is our existing code. Now let's begin. Till now we have seen how to organize our code in different modules, but for this game we are going to create a package of game, and that package will contain all of the logic and everything that goes for creating a nice game. So here I'm going to create a package called as game, and as you know, making a package is very simple. It's just like creating a directory. So let me create a directory, let me call it as game, and let us create our init file so that Python knows that this is a package. Now let me drag and drop this file inside my package. Yes, I want to move. Now let's begin with our code. So let us get started. Let me open up this file and let's see. The first one we have for the character type. So what we want to do is we want to make our game as modular as possible. So what we are going to do is we are going to take out everything and everything goes inside its own module. So inside my package of game, let me create a module by the name of character type.py. I simply have to copy and paste everything. So right from here I need the imports. Let me take all of this, let me cut it out, go to my character type and paste it. Let us see what's next. The next one is our character. So let's create one more module inside our package of game and let us call it as character.py. Again I simply have to cut all of this. So let me take everything from here, let me cut it out and go and paste right over here. Let us go back. The next is for the superhero. So again let us create a new file, superhero.py, and let me take everything from here, let us cut it out, go to our superhero file, let me paste this, and we can see we have a couple of errors, and that's because we need to import character and character type. So let me go to the top. Now here, since we are working inside a package, we need to say that from the current package, the module of character, I want to import the class of character. The same thing for character type as well. So from the current package, I want you to go to my module called as character type. I want you to import my character type. Now if you save, all of the errors will go away. Let us go back. The next one is for a villain. So again, go back right over here. Let us create a new file called as villain.py and let us take all of these things. Let us cut it out and paste it right over here. Also let us do our imports. So from character, import character, from character type, import my character type. Let us go back. So the next one is for the life. Let us create a new file called as life.py and let me take all of these things till the last, till here. Let me cut it out and paste it right over here. Let me save it. Let's go back to this file, and if you see, this file is pretty much empty now. So let me delete all of the blank lines from here. I don't require all of these things. Let me take out the documentation as well because we already know what it's all about. We don't require this as well. So let me go on the top. So we have a much smaller file this time, and let's see how we can improve even further. But before we can go a little further, I wanted to add a couple of more classes. The first class that I wanted to add is for a player. It would be so nice to have a player. So let's create a very simple class for player. So let me say my player.py. This is going to be my class of player. I can define my init. The first is obviously the self. Next could be for the first name. This is string. Next for the last name. This is also a string, and this returns nothing. I can say self.firstName is equal to my first name, and self.lastName is equal to my last name. Let us create the wrapper method. So I can say repr and self. This returns a string, and it can return saying that this is a class of player. Let us create the string method as well. So our self, this returns a string. So let me just return the first name and the last name. So I can say self.my first name and self.my last name. That's it. And this time we are going to have one more class, and that class is for the game state. Just imagine when we are just starting with the game, we can have a different state, maybe initializing. When we are playing, the state changes from initializing to in progress. And at the last, the state can change to either win or lose. So we can keep a track of the state by creating a new class. So let us create a new module right over here. So this is going to be called as my game state.py. For this, I am going to use the enum. So I can say from my enum, I want to import enum and auto. Then I can say my class of game state, which inherits from enum. Let me add some documentation. First one we can call as initializing. So set it to auto. Next one for in progress, again set it to auto. The last two would be for the win and the lost. Let's take a moment to review what we have done up till now. We have created a module for each of the objects inside the game. But if we have a look at all our modules, they are basically structures for something. For example, character, this is a structure for something. Character type, again a structure for the types of characters. Game state, the types of game state that we can have. For player, again we just have a structure. The same thing for superheroes. So this is just a structure for superheroes, and so on. So technically we can call all of these structures as schemas. So schema simply represents a structure, and that's it. So let's create another package inside the game of package called as schemas, and let us put all of this functionality inside that package. So inside my game, let us create one more folder by the name of schema, and to make this folder a package, let me create file inside of this. It has to be again init __.py. So let me collapse all of these things. On the top level, we don't have anything. We just have a package of game. Inside the package of game, we have another package called as schema. Now let us move all of the schemas into the right package. So my character type, my character, game state, life, player, superhero, and villain. All of these things will go inside my package of schema. Yes, I want to move everything. So let me collapse my schema right over here. So inside my package of game, we have three things. First one is another package of schema, then our init file, and last one is our game file. Now let us go back to our game file. Let's see what's next. Here we can see that we are retrieving all of the superheroes, or we are retrieving a single superhero. Normally in an application, you would have a database where you will store all of the superheroes and all of the supervillains, and that database would be controlled by something which is called as a models. So just to get a feel of models, let us create one more package inside game. So inside game, let me create a folder called as models, and inside this folder let us create a init file to make it an package. Let us go back to my games file. Now what happens in an application whenever you want to interact with a database? So you can imagine all of these things to be a part of the database, because this is the place where we are storing all of our data. So normally a model would do all of these things for us. So let's go into models and let us create one model for our superheroes. So this becomes my superheroes.py, and let us create one more model for our villains. So this would be my file for villains.py, and let us start writing our code inside of this. So first let me go to my superheroes. So let us declare a class called as superhero model, and let us create the init method. Now this init method does not take any argument because we don't need anything, and this returns nothing. Now for the instance variable, we can simply return all of the superheroes or a single superhero. So let's see how we can do that. We can declare an instance variable called as self.all, and we can return all of the superheroes. But let's see how to do that. For now, let me assign it a blank list. Let me go back to my file of my game. Here I just want to cut out all of this functionality for get all superheroes and get superhero. Let me cut it out, go back to my models file, and let me paste everything right over here. Now since this belongs to the class, I want to take it inside, so let me take it inside the class. And since now these are members of the class, the first argument has to be self, and here as well the first argument has to be self. Now let's see what to do next. Now this method called as get all superheroes, it returns a list of superheroes. So this means that this is the schema of the superhero. So let's import it. Let me go to the top. Now what happens is we are inside the package of models, and the schema of superheroes resides in some other package called as schema, which is right over here. So here we can say from my package of game, I want to go to the package of schema, and from here I want to go to the module of superhero, and once over there I simply want to import my superhero. Now you can see all of the errors are gone. Let me save this. The next thing is this is complaining because we have not given the types for this one. So self.all is going to be a list of all my superheroes. Right now it is blank, but we can easily get it from this method. So I can say this is just my self.get all superheroes, and that's it. So what this method is doing is it already has the data for all of the superheroes. On this line it is creating a list, and on this line it is returning that list. So we have access to all of the superheroes. Now what happens here is, since we have an instance variable called as self.all, we don't have to expose this method to everyone, and so we can make this method as a private method. And you know the way to make it private is by putting an underscore. So this syntax has to be updated right over here. So this also becomes my underscore. Now let us go to this one. So this has to be my self dot underscore get all superheroes. And in fact, we don't require this line at all, because this time we already have a class and we already have access to all of the superheroes inside our instance variable called as self.all. So what we can do is we can take out this line, and here we can simply check for the length of self.all, and this also gets updated to self.all, and everything is looking beautiful. Let us also create the string method right over here. So we can say define my str. It takes self and it returns a string as well. Now let's see what we would like to display. Now since this model represents our data, we can simply print out a list of our superheroes. So let's do that over here. So what we can do is we can simply print out the names of our superheroes inside a list. Let's see how to do that. First, let us create a list for all of the names. So this can be a list of string, and let me assign it to a empty value. Then let us just populate this list with all of the names of the superhero. So I can say for my superhero in my self.all, I simply want to append to my list of names. So I can say name.append, and each time I want to append the name of my superhero, so I can say my superhero and his name. And let's see, we have an error, missing return statement. Oh yes, we are not returning the list, so we can say return my list of name. Now we have one more error, and this error is because the return type is a string, but we are returning a list. So let's do one thing. Let's use our formatted string. So I can use my formatted string, and let me put this inside my curly brackets. Now everything is looking good. Let us repeat the same thing for our villains as well. So let me copy all of these things from this file, go inside my models, then to my villains, and let me paste over here. So this becomes my villain, this becomes my villain, this also becomes my villain, everything changes, this also becomes my villain. Again, here we have a villain. Let's change this one as well, and this also needs to change, so this will be villains. We don't have this method as of now, but let us go to the games file and let us copy everything right from here. So let us cut all of these things and go inside our villains model. Let me paste everything over here, and let me take everything inside my class. Now since this belongs to a class, let us add self, then this becomes a private method. Then we need to add self over here. This line needs to go. This line becomes my self.all. Same thing over here, this also becomes my self.all, and this is just for our super villains. Everything is looking really good. So till now what we have done is we have segregated our code as per its functionality. Wherever we had only the structure, all of those files went inside my schemas, and where I have to interact with my database or my data, those files went inside my models. Now let us go back to our games file. So this is my game file right over here. Let us start deleting all of these things which are not required. So let me take it up. If you see, we would have a bunch of errors. Now let's try to work on this file. Now this file is all about the game and the actual logic. So this is the place where we are actually implementing the game. So the first thing that I want to do is I want to rename this file. Now since this file is all about implementation, I like to call this file as just IMPL, so which stands for implementation. You are free to name this file whatever you want. You can call this file as your logic, your brain, or anything that you want. But for me, implementation makes much more sense. Now let's see what we can do inside this file. First, let me close this folder and this one as well. And let me only open this file. So this is where we are working right now. Our implementation is all about a game. So the first thing that we require right over here is we require a class of game. This class will keep a track of everything. It will keep a track of which player is playing the game, what is the game state, is the game in progress, or someone has won or someone has lost, what is the state, who are the superheroes and who are the supervillains. And this class is also going to control all of the methods that we have defined over here. So it's going to control our attack and our win or lose as well. So let's create a class. So this class is like the implementation of the entire game. Let us create a class called as game. Let us define the init method. It takes a self. Now this init method only requires a player. We will just take one player and we will initialize a blank game in return. So let's accept one player. The type is a player. Now remember, inside our schemas, we already have a player which is right over here. So let's go and import the player from our schema, and we need to do one more change. So this is not a single schema, this is schemas. So let us add an S. Yes, we want to make some changes. Now since we have changed the name of the package, let us go to our models. So by default, Visual Studio Code is going to do this for you. But if it is not happening inside your IDE, then make sure this is schemas, and for villains, this also needs to be schemas. So let me go back to my implementation file. So here on the top, I can say that from my current package. So remember, right now we are directly inside our package of game. So let me collapse my models and schemas. So you can see our file of implementation is at the same levels as our models and schemas, and game itself is a package. So we can say from the current package, I want you to go to the package of schemas, then go to the module of player and import our player. Let us go to this line right over here. So our init method returns nothing. Now let's see what kind of instance variables do we require. First, let me write all of the instance variables, and after that we can populate them. The first one would be for the player, and we already have the data that's right over here, self.player. Next, I want to keep a track of the game state, so I can say self.state would be my game state. We will import that shortly. Let us create the next variable first. We also need to keep a track of all of the superheroes and all of the supervillains. So let us create an instance variable for all of the superheroes. Let me get my spelling right. This has to be my superheroes. And we need one more variable for our villains. Now let's see how we can populate all of these things. For the state, we already have a game state defined inside our schemas. So we can say from the current package, go to schemas, go to my game state and import my game state. Now let's see, the first time we don't have any data, so we can assign the state to initializing. So we can just say my state would be game state dot initializing. Now let's see for the next one, we can get all of the superheroes from our models. So let's go and import our models as well. So I can say from my current package, go to my models, go to my superheroes and import my superhero model. Let's do the same thing for our villains as well. So dot models dot villains, import the villain model, and here we simply want to initialize it. So this becomes my superhero model, this becomes my villain model. Now just remember, when we created the model, so if you go over here and if you see the superheroes, you can see the constructor does not accept any argument. So that's what we are doing over here. We are not giving any arguments because it is not required. And with this, we can easily have access to all of the superheroes and all of the supervillains as well. Let us create the wrapper and the string methods for this as well. So we can say my wrapper method takes a self, this returns a string, and let it return that this is a class of game. Next, let us create an string method as well. This returns a string. Now let's see what we would like to return. Maybe we would like to return all of these details on separate lines. So let's see how to do that. So I can say I want to return a formatted string. Let me collapse my sidebar for a while now and let me take it up. So the first thing that we want to display is obviously the player, and we can say self.player. Now we want to display the state on a next line. We can use a small trick over here. We can say backslash and n. So this is going to create a new line for us automatically. And on the next line, I would like to display my state. So I can say the state would be my self dot, let me put a comma, here as well. So on the next line I would like to display my superheroes. Oh, I need a code right over here. So I can say my superheroes would be my self dot superheroes. Let me get my spelling right. Let me put my comma, and we require one more line. Now since this is getting a little long, let me split this. So let me put a brackets and let me take it down, and let me add one more formatted string right over here, and this would be for our villains. So we can just say that self dot our villains. Let us go below and let us take all of these things inside our class of game. So let me copy all of these things, the method of attack, the method of simulate attack, and we also need this method of win or lose. Till this point I want everything inside my class. So let me take it inside. Let me save the file, and now we don't need all of these things because right now we are just creating a package, and we will see how to use this package in the future. So let me take it out, and you can see we have a bunch of errors. So let's try and work with our file. So let's work with this one. So this is the place where the attack is taking place. So I can just say this block is for the attack. Now since this belongs to the class of game, we can write self. Same thing will happen with our simulate attack as well. So I can just write self right over here. So let me save this. Again, this one, this also has to take myself. Looks good. Now let us go back. Now let's see how the attack is going to take place. Now let's fine tune our attack logic. Let me put some documentation. So whenever we start an attack, we can change our state from initializing to in progress. Inside this we can say self dot state. So when we start an attack, it changes to my game state dot in progress. Then let's print out a nice line saying that start in attack, and if you want to check the state, we can simply print out the state as well. So you can just say my self dot state. So let us go down. Now let us have a look at this line. At this line we are trying to get a single superhero, but now we have this method inside our model. So let me open up the file. Inside models, if you go to our superhero, now we have created a class called as superhero model, and inside this class we have a method called as get superhero. So let us try to reference this method right inside our implementation file. So what we can write here is we can simply say that we want to go to the self dot our superheroes. So remember, this superhero is actually the superhero model. Let me show you one more time. So you can see this superheroes is actually the superhero models. So we can access this method right over here, get superhero, and that's the way we can get our superhero. Let's do the same thing for the villain. So I can say my self dot villains dot get villain. Let me collapse my sidebar. Now let's go to this line number 43. So since this method belongs to the class, it has to be self dot. Now what this method is doing, it is actually doing the attack. So we can have a little better naming convention. So we can just change the name from simulate to do the attack. Let me change right over here also. And we can do one more thing. We can mark this method as private because this is all about our internal logic. No one has to know how we are doing the attack. It's up to us how do we implement the logic. This also needs to be my double underscore. You can write a single underscore, it's up to you. So this simply means that this method is just private to this class. Now we have a bunch of other errors for superhero, villain and life as well. So let's import all of this and all of the errors will go away. Let us go to the top, and here we can say from my schemas, from my superhero, let us import my superhero schema. The same thing we can do for the villain as well. So from dot schemas dot our villain, let us import the villain schema, and we can do the same thing from dot schemas dot my life. Let me import my life, and let's see what's happening next. So you can see a lot of the errors have gone. Now this is a pretty easy error to fix. We just have to import final and that's it. But let's not do it right over here. Let us create a new file called as constants. Now let me explain why do we require a new file called as constants. There may be times where we can have multiple constraints for our game. For example, let us go right over here in this method of attack. You can see that we have hardwired the value right over here 3. So we have 3 over here because we have 4 superheroes and we have 2 over here because we have 3 supervillains. So we can think that all of these are simply constraints for our game, but we can make our game much more modular. What happens if you want to attack 4 times, 5 times, or what happens if we have multiple superheroes or multiple supervillains? We need to have a very easy method of doing all of these things. So for this convenience, let us create a new file inside our game. Inside my package of game, I want to create a new file called as constants. Let me add some documentation. You can imagine this file to be just a helper module, and that's what this is doing. The first one was for the number of attacks. So we can just say the number of attacks and we can assign a value of 3 over here. Now let us go back to our implementation file, and instead of hardwiring 3 over here, let us import that and let us use that constant over there. So we can say from current package, go to the module of constants and import my number of attacks. So let us go down and let us use that right over here. Now we can increase and decrease the number of attacks as desired. Let's go little down over here. Let us do the same thing for this one. Let us take it out. So these values are never going to change. They are going to be constants no matter what. So let me cut it out. Let me go to my constants. Let me paste over here. Let me fix the indent. Now you already know that we don't require a final keyword, because when we name all of this in uppercase, by default MyPy or our IDE is going to treat them as constants. So we can take this one out and this one as well. And in fact, we don't require string as well because our IDE would be able to infer all of those things. Let us go back to our implementation and let us import it. So let me go to the top. So from constants, I also need to get my winning message and also my loss message. Let us go down. Now since we already have access to winning and the losing message, we don't have to do anything. Let me take out this line. This is not required. Now let's see what's happening right over here. Here we also need to update the state of the game. Suppose we are winning, then we can say self dot the state would be my game state dot win, and in case we have lost, then we can say game state dot lost. So now we can keep a track of the state of the game at any given point of time. There is one last thing to do in this file, and that is right over here. So here if you see, we are using 3 and 2 because we have 4 superheroes and we have 3 supervillains. But what happens if we decide to add a couple of more superheroes or a couple of more supervillains? So let's try to make this code a little bit more modular as possible. So what we want to do right over here is we can simply say I want to have the length of my self dot superheroes dot all minus of 1. Now remember, your index is always 1 less than the length, and that's what we are doing right over here. Let us do the same thing here as well. So I can say the length of my self dot my villains dot all, and I want to minus of 1. The last thing to do inside this package is to create a file, and let us create a file. Let us name it as game.py. Now this file will have a single line of code. So first let me write it and then let me explain what I'm trying to do. So I can say from the current package, I want you to go into my implementation and I want you to import my game as well as my player, and that's it. So what we have done is we have created an API, which means your application programming interface. So whenever some other developers have to interact with your code, or if they want to play your game, they simply needs access to just this one file game.py. They don't have to import any of these things: models, schemas, constants, implementation. Nothing of those things are required. All of those things are our internal implementation. The clients don't need to know all of the logic. They simply have to consume our logic. That means they simply have to consume our API. So now you are getting the logic. We have been creating our application in different layers. So this was a layer just for our schemas. Models was just a layer for our database, or rather data in our case. And this file acts as our API. Now let us create a client file and let us play our game. So outside the game, let us create our client. So let me call it as main.py. So by convention, main is always going to be the most important file or the place where our program starts. And as a convention, we require a function which is called as main. So this is the place where Python will start all of our execution. So this file can also be thought as your client. Let me put up a documentation. So this file, or rather this model, is just as a client. It is going to consume our API game, and that's it. Let us import our API. So we can say, from my package of game, I want you to go to the module of game, and from here I simply want you to import my class of game and player. Now this looks a little odd, game.game, but what we can do, we can improve our design with a small trick. So let us go back to our package of game and let us go back to the module of game. Let me copy this single line and let me put it inside the init file. So this init file is for the game. So I can just put my init file right over here. Now I don't require this module. Let me take it out. Yes, move to trash. Let me add some documentation over here. So since we have this inside our init file, we can simply write from game import game and player. It becomes so simple. Now let us go back to our API file, which is this one. Now the beauty of creating APIs is with time your game is going to evolve, and sometimes you may have some breaking changes. So this was our first version. Maybe you can have a version 2 or maybe you can have a version 3. But at that time the client does not need to update his code. We can refactor all of the code inside, but just keep this API file the same. So you see we have a lot of advantages of breaking our application into multiple layers. Now let's get going to the last part and let us create the main method where we can actually play our game. And fortunately this is the most easiest part. Let me collapse my sidebar. So this is returning nothing, so I can say none. Let me put some documentation. This is the place where our game begins. Let us create the first player. So we can say my first player is my player and Louis. The last name is Zappa. Now let's create a game for Louis. So we can say we want a game for our player number 1. Here let us just check the state of the game, and since we are just starting the game, our state would be initializing. So let us just check if that's the case or not. I want to see the state of my game 1. So game1.state. And the last thing to do is we need to invoke our main method. So let me save the file and let me try running it. Beautiful. So as you can see, we have the state of initializing, and that's what we expected, right? Now let's start with the attack. So here we can say I just want to have my game1.attack. But before that, let us try to print the game itself. So let me say print, I want to print my game1. Let me comment this for a moment, run the file, and this is how your game looks like. The player is Louis Zappa, state is initializing. This is the list of all our superheroes, and these are all our supervillains. Beautiful, isn't it? Let us go back and let us have the attack first. So we can say I want to have my attack, and after the attack I want to see if I am winning or if I am losing. Let me save it and let me try to run the file. Amazing. So we have a very beautiful output. Unfortunately we lost and Thanos killed our Avengers, but it is such a beautiful experience. Let us go back and I want to make one last small change. what we can do is we can create something which is called as method chaining. That means, what if we have a syntax like this, game1.attack, and here we can just say dot win or lose. So this will look so neat and nice. Let's see how we can do that, and it's very easy to do it. Let me open up my sidebar. Now remember, all of the implementation happens in a single file. So it becomes very easy to find out where do we need to make our changes. And all of the changes happens in this file for implementation. Now since we want to have method chaining, we simply have to return the game. So that means on our method of attack, we simply want to return the game itself. So I can say this method is going to return my game. Let me collapse my sidebar. And I also need to return, so at the bottom right over here, let me go on the next line. I simply have to say that I want to return self. Now in order for this syntax to work, we need to import one more thing. So let me go to the top. The first thing that we want to do is from future, I want to import my annotations. Now we can use this syntax. Let us do the same thing for our method of win or lose. So this returns a game, and at the bottom, let me just say, let me return self. Beautiful. Let me close this file and let me go to my main file. We can assign the game back to our variable. So I can say game1 is equal to my game1. Now let us print the state one more time right over here. So what's happening is we are starting with an attack, and then we are checking if we are winning or losing. Initially the state would be initializing, and after the game it could either be win or it could either be lost. Let me take this little up. So the first thing that we want to do is we want to print the game, then the status, then we play the actual game, and let us have the state back again. So let me save this and let me play this game. So here it is. So this is our game right over here. The player is Lewis. State is initializing, superheroes, supervillains. Beautiful. Then we are starting the attack. After we start the attack, the state changes to in progress. This is how the attack is taking place. But unfortunately, Thanos has killed Avengers. So our final status is game state lost. So let us play one more time. Let us see if we are winning or not. No, lost. No, lost again. Lost, lost, lost. Oh, this time we are winning. It's so amazing. So here you can see that when we won the game, our state is game state win. It's so damn amazing. Let us create one more player and let us play the game for the last time. So let me go right over here and let me create one more player. This player would be Chico Neutron, and let us go down over here. Now just for the sake of nice printout, let us print a blank line before the next game. So here we can say my game number 2 would be my game, and this time we can say my player is going to be my player number 2, and we can start playing the game here itself. So we can say dot attack, and after the attack I simply want to check if I am winning or if I am losing. This method chaining makes our game so easy to use. So let me save the file and let me play the game for the last time. Oh, I think both of us lost. Chico also lost the game, and Louis also lost the game. Let us play the game one more time. No. Oh yes. At least this time Louis has won the game. Before we say we are done, let us have a look at the last time. Now there is no more coding left. I just want to show this file, and this file is called as thinking in layers. So let me collapse my terminal, my sidebar, and let me put this in my preview mode. So this is the last thing that I wanted to show you. Let us try to conceptualize what we have learned so far in this video by making this game. So what we did was we divided our application into multiple layers. Now let's see what we exactly did. You can imagine the first layer was our data layer, and the packages who are responsible for our data layer live inside the folder, or rather the packages of models and schemas. The visibility is private and the role is internal. So what happens is whenever we want to interact with the database, whenever we want to create a structure, all of that code will go only in these packages. The advantage is when we have multiple people working on the same project, all of us can know where to find the data. The next layer can be thought as our business logic layer, and this layer is represented by our implementation, and we have all of our implementation inside this file impl.py. Again, the visibility is private and the role is internal. That means we as the developer of this game or of this library, only we can handle this file. The next layer can be called as an API. The package of game can be thought as our API. Remember, we added a couple of files to our init method, and our client can simply import all of those things from our package. So essentially what is happening is our API is acting like an interface between our internal logic and our consumer. So the visibility of our API becomes public, and our main.py file can be thought as a client because the client simply consumes our API. And I hope this gives you a much better understanding of why we divided our code so much and why we created so many packages. Now that was such an amazing effort, and I would like you to congratulate yourself. This was a pretty tough and a very intense course for a beginner, and you definitely deserve much needed appreciation. You have done an amazing job.